Welcome to this lesson on linear geometry. In molecular chemistry, linear geometry is one of the fundamental molecular shapes you'll encounter. It's characterized by a very specific bond angle of 180 degrees, which creates a perfectly straight arrangement of atoms. This geometry is essential for understanding how certain molecules are structured and why they behave the way they do. Linear geometry describes a molecular shape where atoms are arranged in a straight line. The key feature is that the bond angles are exactly 180 degrees. This occurs when a central atom has two bonding regions and no lone pairs of electrons. The atoms on either side of the central atom are positioned as far apart as possible, creating that characteristic straight-line structure. Let's visualize the 180-degree bond angle using carbon dioxide as our example. Imagine a carbon atom in the center with oxygen atoms on both sides. The bond angle between these three atoms is exactly 180 degrees, forming a perfectly straight line. This arrangement represents the maximum possible separation between the two bonding regions around the central carbon atom. Several important molecules exhibit linear geometry. Carbon dioxide with the formula CO₂ is the most common example. Carbon disulfide, CS2, also has a linear structure with sulfur atoms instead of oxygen. Beryllium fluoride, BeF₂, is another molecule with linear geometry. All of these share the same characteristic: two atoms bonded to a central atom with no lone pairs. Let's examine carbon dioxide more closely. The central carbon atom has 4 valence electrons. It forms 2 double bonds, one with each oxygen atom. Crucially, there are 0 lone pairs of electrons on the carbon atom. This combination of 2 bonding regions and no lone pairs results in the linear geometry with a bond angle of 180 degrees. The reason for linear geometry is explained by VSEPR Theory, which stands for valence shell electron pair repulsion. This theory states that electron pairs around a central atom repel each other and arrange themselves to be as far apart as possible. When there are 2 bonding regions, the maximum separation occurs at 180 degrees, giving us the linear shape. Linear molecules have some interesting properties. They typically have symmetrical charge distribution, meaning the electrons are evenly spread along the molecular axis. Because of this symmetry, linear molecules are often nonpolar. The bond dipoles, which are the separation of charges in each bond, cancel each other out due to the 180-degree arrangement, resulting in no overall molecular polarity. To summarize, linear geometry is characterized by bond angles of 180 degrees. This shape occurs when there are 2 bonding regions around the central atom with no lone pairs. Carbon dioxide is the classic example of a linear molecule. Understanding linear geometry is fundamental to predicting molecular shapes and properties in chemistry.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.